Well, hi there, sports fans, and welcome to another exciting episode of Physics 12. And today's topic is lesson 1.6, which is vectors in polar form. Now, we've done some work with vectors already, but we're going to go in a little bit more detail in terms of adding and subtracting vectors together and that kind of thing. So today we're going to actually look at how we express vectors in polar form. So the first thing that we want to look at is the addition of vectors. And in this case we have a very simple example. We have a couple of vectors in one dimension. We have one vector that's 8 kilometers in magnitude to the east, and then we have another vector that's 6 kilometers in magnitude also to the east. So when we add those together, then we can just simply add the two numbers together, and our resultant will be 14 kilometers to the east. Now again, you have to be concerned about direction when you're talking about vectors. So if instead they were both in the same direction, and let's say one of the vectors was 8 kilometers to the east and the other one was 6 kilometers to the west, now you would actually subtract them. And so your resultant vector, by adding these two vectors, is going to be 2 kilometers to the east. So when they're in one dimension, it's pretty simple. All you do is either subtract, add or subtract, as the case may be. And again, you have to make sure that you're careful about the signs when you're looking at the direction of the vectors, which tells you whether you need to add or subtract the numbers from each other. Now, we can add vectors together. Graphically, we can do this. So if the motion is in 2 dimensions now, then the situation is a little bit more complicated, but not too much, nothing that you haven't seen before. So here's the addition of two vectors. We have vector D1 is 10 kilometers to the east, and we have vector D2, which is, 5 kilometers to the north, I believe? 5 kilometers? Yes. So it's 5 kilometers to the north. Now we're going to add these two vectors together, D1 and D2. So how do we do that? Well, as you can see, we put them together in this way here. So now they're actually in 2 dimensions. What makes this example easy is that they're at right angles to each other. The one vector was directly east and the other was directly north. So we have a right angle here. So we can just simply use the Pythagorean theorem to find the magnitude of the resultant, which is D1 plus D2. So that'll give us the magnitude, the Pythagorean theorem, and then we just use simple trig ratio, the inverse tangent, in order to find this angle here. So we express this vector then in terms of its magnitude and its direction, and in this case, in polar form, we use the angle there, like so. Now, again, when you add the vectors together, adding, like all numbers, it doesn't matter what order you add numbers in. You'll still get the same answer. So if we first put D2 here and then we put D1 on there, as you can see, our resultant vector is still the same. So adding them together, it doesn't matter what the order is. Subtracting does, of course, and you'll see that. But adding, the order doesn't matter when, which order you do that. So even if the vectors are not at right angles, they can still be added together graphically quite easily by using what we call the tail to tip method. And this is indeed the way that you add all vectors together, is from the tail of one to the tip to the other. You put them together, and then the resultant is the one that goes between between your starting point and your ending point, like so. So we can add these vectors together quite easily here, as you can see. We put this one over here, and this one has gone over here. And again, you put the tail of one to the tip to the other. And vector 3 now is down here. And again, the tail of 3 is joined to the tip of 2. And then your resultant is from your starting point to your ending point right here. So that's from the tail of your initial vector, the one that you started with, to the tip of the last one that you're adding, the last vector that you're adding, like so. Okay, so just a little bit more on the tail to tip method. So anytime that you're adding two vectors together like so, and you want to put the tail of one to the tip of the other one, and your resultant will be from the tail of the first one to the tip of the second one. And that gives you the resultant vector. And you've got to be real careful that you don't put the two tails together, because that'll not give you a correct result. Make sure, as it says, tail to tip, so the tail of the second one to the tip of the first one, and then the resultant will be from the tail of the first one to the tip of the second one, as it is right here. So this one is correct, this is correct here, this is not correct. So you've got to be careful as to where and how you position the vectors when you add them together. Now we can also multiply vectors by scalars. And so if we have a vector that, if we have an example of a vector right here, we multiply it by -1, then all we do is we just reverse its direction. So if you're multiplying a vector by -1, then you're just reversing the direction of it. So that helps when you're subtracting vectors, because this is one of the most confusing things about vectors, is when you subtract vectors, what do you do? Well, all you do is you take, if we're subtracting v1 from v2, then all we do is we write -v1 and then we add the two vectors together. It's really quite simple, but it always causes a whole lot of confusion, so hopefully I can save you a lot of frustration with this right now by, once again, when you're subtracting vectors, just take the negative of the one that you're subtracting, make it negative. So you see we just turned it around, that's all we did. And now you just add the two vectors together. And then you add them in the same way that you did before. So you put the tail of the second one to the tip of the first one, as you can see right here. And this then is your resultant vector. All right, so be real careful, just write the negative of the second one, add your vectors together, and you're good to go. And hopefully that'll avoid a lot of confusion for you. So subtraction of vectors and multiplication of a vector by a scalar. So a vector, it can be multiplied by a scalar, and the result is a vector CV that has the same direction, but a magnitude which is different, which is the factor that you multiplied it by. So if this is our original vector, 1.5 times the original vector would be something like this, and negative twice the original vector would be something like this. And again, the negative then makes the direction in opposite. So a negative vector, the negative of a vector, all you do is you just put the direction into the opposite way. So any vector, it can be expressed as the sum of two other vectors, which are called its components. All right, so now we're introducing the concept of components, which we will be dealing with the entire year. So just about every unit that we do will deal in some way with components. So usually the other vectors are chosen so that they are perpendicular to each other. So in other words, what we do is if we're going to express a vector in terms of its components, then what we do is we take the component in the x direction and we take the component in the y direction. And the important thing to note about this is that they are independent of each other. And so when you get the components, then it's easier to add two vectors together if they're not at right angles. For example, this, okay, well here's another example of just putting them into its components here. So if this is our original vector here, this would be the x component here, and this would be the y component. And they are easy to find just using your basic trig ratios. All right, so the sine of this angle is Vy divided by V, and the cosine is Vx divided by V. And the angle, we can find the angle by the tangent of this length divided by this length right here. So underneath here we've got, and then to find the magnitude, of course, we'll just use the Pythagorean theorem again. Let's put that back down here. All right, so using components then, we're just using basic trig ratios, and the components are at right angles to each other. And that's why we can use the basic trig ratios and the Pythagorean theorem as well. So you can see this may look a little bit messy, but it's really not too bad, because what we've done is we're adding two vectors together here, v1 plus v2, and all we've done is we have broken the vectors down into their components in their x directions and into their y directions. And so once you've done that, then you can just add the two vectors together because they're in the same direction. So we add the v component, or sorry, we add the x components together, and we add the y components together, and that gives you your resultant. So it's really not as messy as what it might first appear. And once you start working with it, then you'll see, you start to get used to it. It's really not that complex. So adding vectors then, in summary, first of all, draw a diagram. Have you heard me say that before? Draw a diagram. Your diagram in any problem is absolutely crucial that you get it correct. And so we add the vectors graphically. We choose our x and y axes, and then resolve each vector into its x and y components. And then calculate each component using just your basic sine and cosine ratios. And then in order to find the angle of the vector, then we use the tangent ratio. And so those are really the only things that we use. So just your basic Pythagorean theorem, tangent ratio, and sine, cosine, and that's about all we use. And just make sure that your diagram is right and your signs are right, your plus and minuses are correct, and then you'll find that you shouldn't have too much trouble with this topic.